Good morning. My name is Yawajing. I am from Jamia Millia Islamia. I am presenting my project for AYEHUM, Robotics for Disaster Management with Yasser Nehal. Actually, he is making the video, so he is behind the screen, so you guys won't be able to see him. Our project, Robotics for Disaster Management, is basically concentrating on the aspect that how robotics can help in disaster management. Disaster management basically comprises of 3 stages. First stage is preparing for the disaster before it occurs. The second stage is the disaster response, for example, emergency evacuations, etc. And the second stage is supporting and rebuilding the society after disaster has occurred. The first and the last stage we have left for the time being. Basically, we are concentrating on the second stage, that is the disaster response. Now, in disaster response, the first thing that happens is the collection of the data in the place where the disaster happened, like climatic conditions, terrain, etc., etc. This thing is done by the disaster response team. Now, we want to add robotics in this stage. For example, if the disaster response team goes into an area where a nuclear leak or a gas leak has happened, now what happens if the team has to collect the data? The team has to expose itself to the dangers of the nuclear radiation or the gas leak to go there and collect the data. Now, if we use a robot instead of a person, so you guys, and it's a common experience, and everybody can understand it. It's a much safer way. So here is the robot we have made. This is basically the prototype we have made here. Right now, you can see it has the belt tracks on it, and this robot has the option of being used with the belt tracks or without it, depending on the terrain where the robot has to operate. Right now you guys can see that I am removing the belts. Now this robot has the capability to operate in the 4-wheel drive mode. Now here you can see the 4 DC motors. The first thing is that this DC motor is an 100 RPM motor with around 600 milliamperes of current rating and 12 volts of voltage rating. This robot, this is the chassis made of the aluminium angles. You can see the aluminium angles. This is of the size of 19 mm by 38 mm, L-shaped angles. The main thing in the surveillance robot is the camera. The camera, as you can see, is the heart of the robot. If we want to do monitoring, that is away from us, monitoring of a place, so obviously we need a camera to do it. So this is the camera module, C3088 camera module using a OV6620 sensor of OmniVisions. In this camera module, the heart of the camera module is the ATmega8 sensor you people can see here. This is the AT-Tiny12 microcontroller. This ATmega8 microcontroller and this 3088 module is being synchronized through this AT-Tiny12. The AT-Tiny12 does the work of synchronizing the camera module and the main microcontroller's clock. We can take the voltage level or the output from the camera in 2 ways: the TTL voltage level or the RS232 voltage level using this MAX232 IC. This is the camera module, and here is the L298 motor drivers that we are going to use to drive the motors. This L298 motor driver has the capacity of 2 amperes per channel and can take loads up to 46 volts. We are basically going to use 2 L298s since a single L298 can drive 2 motors. The batteries we are planning to use are the nickel cadmium batteries. These are 3 batteries, 3.7 volt each. 3.7 volt each. If we combine the 3 in series connection, then we get a voltage rating of about 10 volts. That is exactly what we require for the robots. And otherwise you can use a dry cell or the 9 volt battery that's commonly available. Another third choice we have is use of seed lead acid batteries. In this case, if we use a seed lead acid battery, this option provides us with long-term operation. With the current power consumption ratings of the robot, we can guarantee of more than 12 hours of functioning within a seed lead acid battery. Here is the programmer we are used to programmer we have used to program the microcontrollers, the 80 mega 8 and the 80 tiny 12. The LCD is used to take the data from the sensors and display it. The sensors we have used are basically we have used only a single sensor, that is a gas detection sensor. The gases it detects are of volatile type and combustible type. Otherwise we had also used to plan to use a gamma ray detector and biological detector. Of course it was too heavy in the pocket, or the funds were we didn't have the requisite amount of funds for it, so we weren't able to purchase the gamma ray detector and the biological detector. But we are trying to show the feasibility of the project with a single sensor. If a single sensor can be used with this robot, with this stuff, to show that it's manageable, so other sensors are also quite manageable, and we have some data to prove this also. So this is the complete project. We have the complete stuff of the robot we have shown to you. Of course, this is in an assembled stage. We are going to assemble it and hopefully present to you guys in a good time. Thank you.